All right, so this is, in this playground, we're going to learn some about Swift by doing the TPK algorithm. And the first thing is, this is sort of a cop-out, but there is not a good way in Swift of reading like console input, because Swift is not designed for that at all. It's designed to make iOS apps where there's not really console input. You could read from a file, but not from the console. That makes sense? So what I'm going to do is instantiate an array of 11 things in a for loop. I'm sorry if that's disappointing. That's what we're going to do. So we're going to create an array of integers. So I'm going to say var to say this is a variable called array. And I'm going to say colon, and the data type here is an array of ints. Actually, let me do this. I'm going to say array equals int parentheses. So this is going to instantiate an empty array of integers. Can y'all see this? Is this big enough, the text? Okay. Okay. And then to at least sort of simulate reading these in and doing array manipulation, I'm going to create a for loop, and I'm going to iterate over all the numbers between 1 and 11 and add those to this array. So I'm going to say for, and I'm going to say for num in, and I'm going to give it a range. And the range is kind of a special data type, special kind of function in Swift. And I'm going to specify that with 1 dot 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 11. And then I'm going to put my curly brackets. And if I've done this right, then num is going to iterate over each of the values in that range. And what I want to do is I want to say array.append. I'm going to append a new element that is num as we enter this loop, for each iteration of that loop. You can actually go over here, click on the little I, and it shows you that there are 11 elements in this array. And if you click on this button, you can see that at each iteration of the loop, this is how it changes. It gets one more element each time. So now, if I were to say array, I think I can do this, yeah. In this environment, like this statement isn't something you'd really program because this doesn't do anything. But in the playground, I can do this and see these are the 11 numbers in the array. Make sense? Okay, I'm going to delete that. So we have our sequence of 11 numbers. For each item in the sequence, oh wait, sorry, we're now on this step. The next piece is to reverse the sequence. How would you do that? We could write a function that iterated through the array and inserted each element into the front position of an array. We could iterate through the array backwards and append onto a new array. Or we could say var reversed array equals array.reverse, which is a built-in method on array. And I'm going to say, let's do it this way. Yeah? Who's with me? Sweet. Yeah, so this is nice. This is built in, so some really nice built-in functionality. These are smart kinds of objects. And you can see this is what the reversed array looks like, and that's what we'd expect it to look like. Now, in Swift, arrays are, just like in C, denoted with square brackets. So now we need to iterate over the elements in the reversed array and do something to each element. So first, let's write a function that accepts an integer, does some math with it, and returns another integer. You like that? So don't do this in real life, but I'm going to do it today. So I'm going to create a function called doSomething. So I use the func keyword to say this is a function. I'm going to define this function, doSomething, and doSomething takes in a number, which is of data type int. So note that my data types come after the parameter name, and the colon separates that. Also, I want this function to return an integer. To say that, I'm going to say arrow int. So this is like the definition of a function that says these are the parameters inside the parentheses, and the things that come after the arrow are the return values of the function. So this is the structure, the skeleton of a function. I've got an error here because I said I would return an int, and I'm not. I'm pretty sure that's what the error is. Yeah. So what I'm going to do here, I don't know, let's make something up, just a little bit of math. So let's just return number times number plus, give me a number, 25? 45, okay, plus 45. Let's see if that works. It works? All right, sweet. I didn't know if I had to put parentheses around this quantity. I don't. Swift is pretty, the opposite of verbose. It lets you, it's concise in a lot of its things. It doesn't require as much syntax as other languages. So I do need to define this function before I call it. So now I'm going to say for element in reversed array. That element, this is basically a variable that I'm just making up on the spot that gets used in this loop. So for every element in that reversed array, what am I going to do? I'm going to do something to it. Like literally, I'm going to do something to it. I'm going to apply that function, do something to it. I think what I'd like to do, just so that I can keep all this stored, is I'm going to create a new array. So var modified array, which is equal to basically a new array that I'm instantiating right here, a new empty array of integers. And I'm going to append all the modified elements to the modified array. Does that make sense? I don't know if this is actually keeping in the spirit of TPK. Maybe you were supposed to actually modify the original array. Whatever. We're going to do it this way today. We could do it other ways. So what do I need to do? I need to do something. So I'm going to say that modified array dot append. So I'm going to append. What am I going to append? I'm going to append the doing something to the element, which is my iterator variable. What is that? I think I have an extra one of those. That's all on one line. I'm sorry if that's confusing. Does this make sense?
So you're going to do something to the element and then you're going to add it to the
So we're going to start on the inside and move out. You're going to do something to each element. This is each element in the reversed array, and then we're going to add that onto the modified array. So now if I come down here, I really want to see this, right? So I'm just going to say modified array, and you can see it listed out here. You can click on it as well. I think. I don't know why that's not up there. Okay. I will take it. Now, we have kind of skipped over something, and that is, according to TPK, we should check to see if the result overflows, and if it does, we should alert the user. Otherwise, we will just print out the result. So let me go with the easy case, which is we want to print out the result. If that succeeded, we could say for each element in modified array, I want to print line element, colon, and then here's a little trick they've got. You can do backslash parentheses and embed values into a string expression. So this is a way of concatenating non-string values into a string expression. So this is less interesting to see perhaps here because it's not actually printing it out because it's it's running it right here. There you can see what it would print out. A bunch of different lines that say element 166, 145, 126, 109. Yeah. So that's what it would print out to the output.
You can make a console output box.
In the playground?
Yeah. If you go to view assistant editor, show assistant editor.
Oh, nice. Thank you, Tyler. So there's the console output. Now, I looked into this, and Swift really wants to help you not make mistakes. And overflow is one example of how that works. If you create a number that is the biggest number that a 32-bit integer can hold, and you add one to it, what will happen, right? So you've got the biggest number that you can represent in 32 bits, and you add one to it. You can't represent that number in 32 bits anymore. You've overflowed. That's what overflow means. In lower level languages, the computer would just do what it normally does, and that would result in adding one to this really big number would give you a really big negative number. Because that's what, when you do that low level representation change, that's what it would have. So that would clearly be wrong. Swift just throws an error and won't do it, which is kind of nice. Do you like that? So, and from what I can tell, there's no way of checking to see if that happened. It will just throw a runtime error, or if it can detect it at compile time, it'll tell you this is an error. You have the maximum value that you can put in that, and you can't add any more to it. So it's really trying to find errors early. So as the best I could research, you can't check to see if a result overflows in Swift. It will check if it can do it. If we can determine it at compile time, it'll mark it as a compilation error. And if it's a runtime error, then it's a runtime error, and you can't check it, from what I can see. I believe Swift 2, which hasn't come out yet, but will soon, adds try, catch, kind of exception handling, which is not in the Swift 1.2 that we're working with. So I think that may allow you to do what TPK wants us to do. But this won't. You can't tell that this actually crashes in a runtime way. It just doesn't show the results if you overflow. So I'm going to say that we have achieved what we wanted to do in writing the TPK algorithm. We've instantiated an empty array. We appended numbers to that array. We reverse it very easily. We defined a function, do something. We instantiate the modified copy of the array, which is empty. We do something for every element in the reversed array, and then print out the results. Y'all happy with this? I want to show you one improvement that we could make to make this even cleaner. And that's this. Swift is very functional in the functional programming definition of that, which is, it means that functions are very much first-class citizens. You can do anything with functions that you can do with other variables. You can pass them around, and there's a lot of power in that. So one way that we could have done this more concisely and elegantly is to use the map function. So there's a function called map, which takes a source and a transformation. So it takes a source, which is a source array, and a function to be applied to that array. So we could say map reversed array, comma, do something. And actually, it'll let us use this syntax, which is kind of insane if you think. So what this map function does is the map function applies this function to this array and returns it. If we wanted to save it, we'd need to say that var modified array equals the result of map. But we can at least view it here. So this array here is the same thing that's output by doing this for loop. Isn't that incredible?
It's pretty cool. Very
It's a lot of power that you can do when you have this map function.
That's what functional programming is going to be like from the beginning.
We're there. We're there now. You're living the dream already.
Really that great.
Yes.
Where nothing exists and everything's mapped to each other.
So you could, I don't know if, I would say that this is cleaner, right? So now that one line has accomplished what those 3 lines did, but it's a lot simpler to read. So this is TPK and Swift. Any questions?
You could technically get rid of the initiator and just say it equals map reverse ready something.
Right, so I could just say this. Oh, sorry. And if we were going to be even cleaner in our Swift and embrace Swift, we don't need all these variables. Something that we can do to make our code cleaner is to not use so many variables and to use constants, where constants are immutable pieces of data. If they're not going to change, let's make them immutable. So array has to be mutable because we're going to append to it. But reversed array doesn't have to be. We assign to it as soon as we create it. So I can say let, and let is the way to say this thing is a constant. So now I can let reversed array equal array.reverse. It's a constant. We can't change reversed array later. Likewise down here, I should let this modified array equal that because it's not going to change either. And I know it may not be immediately apparent why you'd want to do this, but it really is the case that when you have variables, right, and if something that really ought not ever be changed, but it does get changed because it can be changed because it's a variable, bugs creep in that way. If you make things that can be constant, it lowers your error, your bug surface. You know what I'm saying? This is the Swift way.
You know what I'm going to say?
No, I don't.
Rust actually, by default, is immutable, and you have to declare immutable. I think that's pretty cool. Just saying.
All right, so this is an improved version of what we have here, and I think it's pretty solid. I'll be happy to share this with you if you wish to see it. It's not the most amazing code ever, but it does show off Swift and even some of Swift's power.
Okay, so can you explain map to me again? That only works for arrays? Is it like specifically designed only work for arrays? Or can you do it with just any other? Which, I mean, I guess you wouldn't really want to with any other variable because it's just useless.
I wouldn't want to map one thing to one function.
Yeah, but that's what it's.
I mean, it's powerful and useful when you're taking a collection and applying a function to a collection.
Need to put it in loop. Okay, that's good. I like that.
So we're good? You guys like this? Yeah.
Whenever I change the top on your row 18 to lead, I was getting error.
Remember I said you can't do that.
It's,
You're changing this array because you're appending to it. So if you make it let, then it's got to be constant. And you don't get to change it anymore. It's immutable. You're stuck with how it was when it was declared. All right. Well, very good. This is Swift. I hope you're beginning to fall in love with it. It is a beautiful language, and it's, I think, vastly superior to Objective-C.